Hello everyone, so we are continuing our um, lesson about the Newton's law. So now we are on forces. So na-discuss na nato unsa ang balanced force and unbalanced forces. When can we say that a force is balanced or unbalanced? No, as what I have stated back in the part 1 of our lesson, which is the first law of motion. So if first law of motion, if it is a balanced force, then naa siya duha ka buok nga clause, which is pwede na ang object at rest will remain at rest and an object in motion will remain in motion in the same speed, in the same direction. Okay? And both of them has zero acceleration because of that. Okay, now we talk about unbalanced forces. That is when na ay force na dili makancel. Okay, during that time. So, pareho tong last na to na topic about the book na siya'y weight, na siya'y normal force, and then na siya'y unbalanced force kay na ay nabilin nga friction na force going to the left. Okay, so those are what we have tackled last time, the unbalanced and balanced forces. But we never really discuss what is force. No, sige na taghisgot unsa na siyang balanced force, unbalanced force. But what is force? Okay, so force is actually a push or pull of an object resulting from the object's interaction with another object. Okay, so whenever there is an interaction between two objects, there is a force upon each objects. No, so dapat nag-interact sila para na ay force. So when the interaction ceases, two objects no longer experience the force. So forces only exist as a result of an interaction. Now, it doesn't mean na layo sila from each other is wala na sila interaction. Okay? So even though they are very far away from each other, they're pwede gihapon na nag-interact sila. So katong mga nag-contact or kanang mga forces nga na ay contact, we call them contact forces. Okay? So those are the types of forces that results when the two interacting objects are perceived to be physically contacting each other. So, contacted sila, no physical contact. The examples of those contact forces, we have first frictional forces because friction cannot won't exist if you are not physically contacting a surface or something like that, or an object, another object. No. Next is the tension or the tensional force. Then we have the normal force. I have tackled that before na walay normal force if wala kay surface or surface. Then we also have air resistance, the interaction between or the contact between air and an object. So kung wala ang contact sa air and that object, walay air resistance. Then we also have the applied forces, imuhang pag-push. Pag-apply nimo og force, of course you need to be to physically contact that object. So it is also part of the contact forces. Next is the action at a distance forces. So those types of forces that result even if layo sila with each other. Nag-interact yapon sila. So it does not need any physical contact with each other, yet they are able to exert push or pull despite their physical separation. So say example ana, gravitational force. Even though you are not contacting the ground, let's say na you are at the top of a building, nakadidto. So if you jump, if kanang let's say na kanang if you're jumping, you are not in contact with the ground. If naka sa taas sa building, you are also not in contact with the ground. Pero you can feel the gravitational force. Okay, that is because the gravitational force is an action at distance force, or it is a non-contact force. Okay, so there are also these. No? So naatay contact forces, friction, tension, normal force, air resistance, applied spring. Spring is also a contact force. Then an action at a distance, we have gravitational force, electrical force, and magnetic force. Okay? Now, force is a quantity that is measured using the standard metric unit known as Newton. Newton is abbreviated as N. No? So 10 Newton means, or 10 N means 10 Newton of force. So iyahang symbol sa Newton is N. And Newton is the atoang unit para sa force. So 1 Newton is the amount of force required to give a 1 kilogram mass an acceleration of 1 meter per second squared, or 1 meter per second per second. Thus, the following unit equivalency can be stated as 1 Newton is equal to 1 kilogram meter per second squared. Okay, so kilogram from the mass and the meter per second squared from the acceleration. So it means 1 Newton, that is force, that you need for you to move a mass, and para mo move siya, ana ng acceleration. Okay? So that is for the force. Now, force is a vector quantity. That is because acceleration, as I have stated here, nasa acceleration, no, from this part. Acceleration is a vector. So, vector siya, ang acceleration, naa siya'y direction. Siyempre, ang force pod, naa siya'y direction. Okay, so force is a vector quantity. A vector quantity is a quantity that has both magnitude and direction. So to fully describe the force acting upon an object, you must describe both the magnitude, or ang value niya, numerical value niya, let's say 10, okay, and iyahang direction. So if it is going, let's say, going downward, then it is negative. If it is going upward, that is positive. Mamana siya sa Cartesian plane na pagtaas, that is positive y. Then going down, that is negative y. Here, it is positive x, and here is negative x. Okay, so the negative here denotes like the opposite of the positive nga direction. So if ang positive direction nato sa y nga axis is the positive, upward, then ang opposite ana of course is the negative, which is the downward. Nga na. Okay. So here, okay, we have an example of a force, or the forces acting on this physics book. So kani siyang book, if it is at rest, and that is because the forces acting on it is balance. Na-cancel siya. Nga naman, kaya pareho man sila og 20. Let's say, this is 20 newtons going down, so that is negative 20. And also, the normal force is pushing the book downward. If this downward force here is our force of gravity, or the weight, then naapay force na going upward, which is the normal force, or the Fn. The normal force is the force that is pushing the book pabalik. No? So, kung pila ang iyahang weight, maupod ang mubalik sa iyaha nga normal force. So, 20, negative 20, ang mubalik sa iyaha is ang positive na 20. So, with that, of course, they'll be cancelled. And pag makancel sila, your net force, let's say F net, saan yung F net? Net force is tanan na siya nga forces. No? Tanan na forces na murag mabilin sa imuha. So in this physics book, your net force is 0 because sila duha na-cancel. And if your net force is 0, it means your object is experiencing balanced forces. No? Na siya'y balanced na force. How about this one? Okay. So, pareho ganina, na siya'y 20 Newton na F grav or the iyang weight. Na siya'y weight nga 20. But it is going down, so it is negative. Then na siya'y normal force that is positive 20 because it's going up. Dara, cancel sila because they are in the same axis. Same silang axis. Basta same galing axis, of course, you can add them and subtract them. Mao na siya sa ato ang last pod na mga discussions. If they are in the same axis, you can add them or subtract them. Depende sa pareho sila direction or not, or opposite. Now here, if this is the y-axis, naa siya x pod na axis. Okay? Ngayon siya dire, friction pushes leftward with 5 Newton. But as you can see here, wala siya partner. Okay? So if the y is 0, but you have this excess nga force nga nasa x, so it means imong F net is kung pila tong wala nimo na cancel. This two are cancelled. So it means 0 na siya sa y. Pero sa x is natay 5 newtons. Okay? So na siya 5 newton and it is going to the left. So it means mo ni siya ang iyahang bilin nga force. So this book here experiences 5 newton nga force to the left. Kaya ang imuha ramang i-count dira is kung pila sa net force, ang imong i-count raman ana is kung pila ang nabilin. Pila ang nabilin niya nga forces. Pag human nimo og cancel tanan. Okay? So F net last na siya. Pag once na na-cancel na nimo na tanan na forces present sa imuhang object. So after na to cancel, then you can look for the kung pila ang nabilin ng force. So here, we have 5 newtons going to the left nga net force. Okay? Then, here we have the type of forces. Okay, so the type of forces, we have first the applied force. Applied force, mauna siya ang force na gina-apply sa object. Like, gina-push nimo siya ang isa ka object, you're pushing. Then that is applied force. Applied force, ang iyang symbol ana is F. Applied force. So it means it is a kind of applied force pag ani ang iyang symbol. Next is we have the F grav, also known as weight. No? So, pareho siya sa weight. It is the force with which the Earth, Moon, or other massively large objects attract another object towards itself. So this is the weight of the object. That is the weight of the object. Muna siya si F grav. Usually, I just put FG on it. Pwede mo put W. Pwede W. Pero for uniformity, FG sa ato hang gamiton. Okay. Now remember not to confuse weight with mass. Weight is very different from mass. I will explain that later. Nganong lahi gid sila. Then we have the normal force. Of course, normal force is pwede siya F norm, pwede po siya Fn. Just Fn. Okay? So F app, F grav, or Fg. Then we have the normal force. The normal force is the support force exerted by, upon an object that is contact with another stable object. No? So like if a book is resting upon a surface, then the surface is exerting an upward force upon the book in order to support the weight of the book. So, basta ga-support gali siya sa weight sa isa ka butang, then that is a normal force. Okay? So, on occasions, a normal force is exerted horizontally between two objects that are in contact with each other. So, pwede po siya ma-horizontal ang normal force. And that is if a person leans against a wall. No? So, kunwari, a person that is leaning against the wall, no? So, it is leaning against the wall. Ang wall pod is, syempre, naaman siya gihatag nga force ang paglin nimo. No? So, ang wall pod is mag-exert back og normal force sa imoha. So, something like that. Now, next is we have the F, friction. It is a friction force. It is a force exerted by a surface that as an object moves across it or makes an effort to move across it. Okay, so we have at least two types of friction force. We have the sliding and the static friction. Okay, so we have F frict. It denotes that this force, this kind of symbol, it notes that kana siya nga force is a kind of frictional force. Then we also have the F air. F air or air resistance, it is an air resistance force, a special type of, it is a special type of frictional force. Frictional force gihapon siya ngano man because the object moves across it, not across the air. So it is a special type of frictional force that acts upon the object as they travel through the air. So that is air resistance or air resistance force, F air. Then we also have the F tension or the F tense. The tensional force is the force that is transmitted through a string. Pwede pod rope, cable, or wire when it is pulled tight. Usually pulling na siya ang tension. It is a kind of pulling force. Okay, so ano siya si tension. Then another one is spring force. F spring. Usually I just put S. F spring or Fs. A spring force is the force exerted by the compression and pag-stretch nimo sa isa ka spring. No? So, kanang iyahang ginahatag nga force, ana, kung i-compress nimo siya, and then imo siyang buyan, then kato siya is a force exerted by the spring or the F spring or the spring force. Ano siya? Now then we have the mass and weight. So ningon ko ganina na the F grav, or what I usually do is I just put FG. So kana siya, si F grav is also known as weight. Now weight is not the same as mass. Mass, na-discuss na to ang mass before, it is the amount of matter in an object. Mass is also the a measurement of inertia. Kung dako kag mass, then dako kag inertia. So lahi ni siya si mass and si weight. Why? It is because weight is a kind of force. Mass is a physical quantity itself. No? We need mass to know your weight. Mass is in kg. Weight, on the other hand, is in newtons. So if you have, let's say, you have this mass, then makuha pod nimo imuhang weight. Because weight, it is a force, or Fg, is equal to the mass of the object times the gravitational acceleration due to gravity, which is 9.81 or negative 9.81 meter per second squared. Okay, so para makuha nimo si weight, you need the mass of the object. So medyo layo gid sila sa each other. Kaso lang, in the daily life, they usually um murag gina-confuse nila ang mass and weight. That is because, di ba, pag magpakilo ta, I know, not pakilo, kunwari, magpa-weight, magpatimbang ta. Pag magpatimbang ta, ang ginagamit nato na unit is in kg. Where in fact, what we are measuring is actually our weight, which is a force. Ang kanang ginatimbang nato sa isa ka weighing scale, naa naman siya si G. Because gravity is all around us, right? So, na siya gravitational force daan. Or I mean, na siya gravity, acceleration due to gravity daan ang ato ang pag-measure sa ato ang timbang. So, the one that we are using, maingon ta na, ang iyang weighing scale niya siya, you are 50 kilograms. But it's actually not a kilogram. It is actually, you are 50 newtons. Kaso, naandan naman gud siya. Naandan na siya sa mga tao. So, the scientist did not bother to change it already kay mao na may naandan sa mga tao. But, still, they are not the same. Okay. So, what you are kanaimuhang weight karon, that is a force. That is a kind of force. So, if you want to know your mass, kani siya nga formula imong gamiton. Okay. So, now, kani siya is, paglahi-lahi ang mong weight, depende sa gravitational field. Even though we are on Earth, lahi-lahi ang G, or ang acceleration due to gravity of each places. For example, in Chicago, Illinois, in the United States, they have the gravitational acceleration of 9.80. Okay, 9.80 then 26 meter per second squared in United States or in Chicago. Then our in Manila, the gravitational acceleration is just 9.78. Okay, so even though we are on the same planet, naay mga lugar nga mas dako ang ilang gravitational field than us. Maybe ang certain factors ana kay mas duol sila, mas baba ang ilahang place kaysa sa atoa, mas taas ang atoa. So the more na taas ang inyong altitude, then the more that you are like away from the core and you are away, mas gamay ang imuhang gravitational field, gamay ang imuhang G. Okay? So that is why siguro na lahi-lahi ta. But katotong 9.81 meter per second squared downwards, kani siya is actually the average of all the gravitational acceleration of all the places in the Earth. Okay, so average na ni siya, kaning 9.81. Kay kung medyo ano na siya, complicated na siya kung ilahi-lahi pag nato kada place. Okay, because there are places nga lahi gyud 9.7 na gud na siya. 9.78. Ang isa is 9.80. So there are also lots of places nga lahi-lahi pod ang ilang total field. Okay, so for uniformity, it was discussed that we will use the negative 9.81 instead. Para dili na magtanaw-tanaw. Tanaw-tanaw pag ingani ba nga lugar unsa ato ang gravitational ato ang acceleration, gravitational acceleration. Okay, so that's why we used this one. 9.81. Okay, now next we have friction. Friction, natay duha, no? So frictional force. So then na siyang frictional force. It is the force exerted by a surface as the object moves across it or makes an effort to move across it. So if you have this object and then it is moving across the surface, ang iyang pag-effort ana will result into a frictional force. So first, we have the sliding friction. Sliding friction, it is when an object slides across the surface. Pag mo-slide siya, just like this, slide nimo siya, that is a kind of kinetic friction, or what we call the kinetic sliding friction. Okay. So, kana siya yung ani ang iyahang ginahimo. So, pag hatag nimo og applied force, because let's say applied force going there, the red one is the applied force, kanang blue one, that is the friction force or the frictional force. Mo opposite siya sa direction sa imong applied force. So if your applied force is going to the right, then your friction is going to the left. Okay? So ana siya. Kani siya ang example sa mga sliding friction. You can see here, they slide. Slide sila. So, if a car slams on its brakes, mag-brake siya, then, pag stop niya, then, ga-move gihapon siya even though nag-stop na siya. So, naa siya sliding friction. Okay? Gi-stop na gud niya ang car, or, gi-stop na niya ang car, and then, ga-move gihapon siya. So, kato siya na force na naa dito is what we call the sliding frictional force, or the sliding friction force. Okay. Next is, so sliding friction forces can be calculated from knowledge of the coefficient of friction and the normal force exerted upon the object by the surface it is sliding across. So it is friction is equal to the coefficient of friction sliding, then multiplied by the normal force. Pila ang normal force na ang gihatag ana nga object, and ang coefficient. Kani siyang coefficient is magdepende siya sa object na ginaslidean nimo. No, so something like this. Okay. So, yan eh. So, pag rubber on dry concrete, the kinetic friction or the sliding friction is 0.7. Pero pag wet ang concrete, mas gamay ang iyang friction. That is why daghay maaksidente sa daghay mas slide or maaksidente pag wet ang concrete. Okay? So that is 0.5. Yeah, 0.5, 0.7 if dry siya. No, so 0.5, 0.7. There is a big difference. There's a small difference, pero it can have a big result. No, so wood on wood, that is 0.3. Waxwood on wet snow, that is 0.1. As you can see here, basta wet ang snow, it is 0.1. Gamay kaayo ang hold sa surface ana imuhang object. So that's why it is very slidey on snow. Just like here, ice on ice, that is 0.03. Slide na siya kayo. The more gamay siya, ang imuhang value diri imong coefficient, the more that you will expect that your object kay mas mo slide siya ana nga surface. Okay. Next is we have the static friction. Static friction results when the surface of two objects are at rest relative to one another, and the force exists on one of the object to set it into motion is relative to the other object. Static friction. Static friction is they are not sliding with each other. Static, from the word static, at rest siya. Even though it is at rest, naagyapan siya friction. So kalahian niya sa sliding friction. So sliding friction man god is, it is a kind of kinetic friction. So it means kinetic, nagdagan imuhang object. Pero kay static friction, naghatag ka og applied force, as you can see here, naghatag ka og applied force, pero wala ni budge ang imuhang object. Wala ni move ang imuhang object despite applying force. No? So, katong friction nga nag-counteract ana niya is what we call static friction. So, for example, here, naghatag ka og 5 newtons na applied force. No, this is your applied force. Pero walay motion. Pag walay motion, it means kung pila imong gi-apply nga force, maupod ang iyahang friction. But here, this is a static friction. No? So, static. So, kay wala may motion. So, kung wala motion, it is a friction that is static. Pero pag naanagali siya yung motion, then dili na siya static. Of course, it is now a sliding friction. No? So, kunwari, hatagan niyo siya 15, pero wala gyapon motion. So, it means, ay ang static friction is also 15. Mo equal na siya kung pila mo hang applied force. Okay? So, mag-equal na sila duha until ma-move na ni siya. No? Na siya motion. So, let's say 25. Hatag 25 nga applied force. Pero, instead of wala siya motion, na siya motion. So, it means, ano na lang. Let's say that naghatag ka og 5 newtons. So, pila mo hang friction ana, that is also 5 newtons. Again, para clear. F stat. Statical friction. Okay. So, kung pila mo hang applied force ana mo equal si static friction. Kunwari naghatag ka og 15. Wala gyapon siya motion. Wala siya oops, sorry. Wala gyapon siya motion. So, it means that equal gyapon ang yung static friction. Pero, paghatag nimo og 20, let's say 20, instead of 15, this will be 20. Okay. So, instead of 15, naghatag ka og 20 newtons. Dayon, instead of nag-rest siya, na siya motion. So, it means 15 is the limit of your static friction. Kini-move naman siya pagka 20. So, pag 20 newtons na siya, na siya motion, your friction becomes a sliding friction. So, magdepende na dayon na siya kung pila ang imuhang coefficient sa imong sliding friction and the normal force. Ito siyang F sliding na to. Okay? So, magdepende na siya dire. Basta kay si static friction only exists if your object is not in motion. Remember na namin yun. Okay. Okay. Now here, this is the mass and the weight. No? So, example rin niya siya. So, if we have an object that has a 1 kilogram of mass, kung nakay 1 kilogram of mass, then ang iyahang weight is 9.8. Remember that weight is equal to mass times g. So, that is mass, which is 1, then 9.81. So that is 9.8, around 9.8. So if we have an apple that has a weight of 0.98 newtons, so that the mass is around 0.1 kilogram. Sabi. Okay. So if Patrick is 25 kilograms, so 25 kilogram multiplied by 9.81, so that is 245. Oops, that's so big. 245. Okay. Now, if Alfred is 980 newtons, then the mass is 100 kilograms. So, tanawon na ninyo, or gamitin na ninyo siya nga formula when you are converting from weight to mass. No? So, you are solving from weight to mass. Another example. So, different masses are hung on a spring scale calibrated in newtons. So the force exerted by gravity on 1 kilogram is 9.8. The force exerted by gravity on 5 kilogram, so 5 times 9.8 or 9.81, that is 49. So the force exerted by gravity on 98 newtons weight, so 98 divided by 9.8, so that is 10. So the force exerted by gravity on 70 kilogram, that is 70 multiplied by 9.81, so or 9.8, so that is 686 newtons. So ano ra siya pag ato ang i-turn into weight ang isa ka mass or mass to weight. Okay. So number 3. So when a person diets, is their goal to lose mass or to lose weight? Okay, so here is it is more about ang terminology na ginagamit sa mga tao. Okay, so ang term na ilahang ginagamit is losing weight. Now, magpa-lose weight ko, kay ganahan ko, maniwang ko. Ana sila. Okay, but actually, when you are nag-diet ka, your goal is to lose mass. Okay? Because kung weight ang imong ginalose, pwede naman ka moadto og laing lugar. No, pwede ka moadto sa laing lugar para gamay ang G. No, so kung mas gamay ang ilang G, okay, 9.78 ang ilang G, then of course, mugamay ang imong weight because of that. But if you are losing mass, you are wishing to remove your fat. No? Pag mawala imong fat, of course, it is a kind of mass. No? So, mass ang imong ginapalesen ana, dili ang imong weight. Because if it is weight, syempre, pag naa ka sa moon, gamay man gid ang imong weight. So, moadto na lang kag moon or moadto na lang kag laing lugar if you want to lose weight. But if you really want to have a you want to remove the fat of your body, then you are reducing the amount of matter in your body, and that is mass. Okay, so if you want to lose, or if you want to diet, it means you want to lose your mass. Okay, next is we have the free body diagram. Free body diagrams, or the FBDs, is a kind of pagdraw sa mga forces that is present on that body. No? So a free body diagram are used to show the direction and the magnitude of all the forces acting upon that object. Okay, so it is a special example of vector diagrams. So these diagrams, ginagamit ni sila in force in second law of motion, in first law of motion, na ginagamit na sila when you are tackling about forces. No? So, to draw a free body diagrams, of course, you need to draw your body or the object as a square. Bahalag dili square ang object. Let's say it is a ball. Okay lang nga dili siya circle ang imong i-draw. Square gihapon na siya imong i-draw once it becomes a free body diagram. No? So, let's say this is a ball. So, still it is a square. Then, kung pila ang iyahang or kung daghan ang iyahang forces, ibutang nimo ni siya dira. Let's say, of course, it is an object, it has a weight. So, pag na siya weight, of course, the weight is a downward force. So, kani siyang arrow, nagdepict na siya kung asa ang direction sa imuhang force. So, the direction of the FG or the weight is going down. Let's say that the weight is 5 newtons. Okay? So, if ang imuhang free body diagram is naa sa surface, then naa siya normal force. So, kung pila ang iyahang FG, maupod ang iyahang normal force. So, this is a simple free body diagram of a ball on a surface. Okay? So, wala siya nag-move. Nga naman. Because, wala siya nag-move kay at rest siya kay balance man ang iyahang object. But it doesn't mean nga balance ang iyang forces at rest na siya. Diba? Sa first law of motion, it can be moving and it keeps on moving or it is at rest and then it will keep on resting. So, kanila siya, sa ato ang example is the ball is on a surface. So, ball on resting on a surface. Okay, something like that. So, if kaniyang iyahang prompt, no, kaniyang iyahang gina-explain, so, ang pagdraw ng free body diagram is like this. So, that is the use of the free body diagrams. So, just like here, there's another type of free body diagram that has 4 forces acting upon the surface. Upon the object. First, we have the weight, which is the F grav. Then we have, of course, ang pares niya is the normal force. And if you have applied a force, naapod siya friction. But, objects do not necessarily na dapat upat gyud ang ilahang force. Dili tanan nay upat. Nay uban duhara. Okay. So, nay uban na isara ay tulora. Okay? So, something like that. So, depende na siya kung sa iyang situation. Sa situation sa isa ka object. So, the only rule sa ato ang free body diagram, the only rule for a free body diagram is tanan nga force nga present na makit-an gid nimo is naa dira. Naa sa imong pag-drawing. Okay? So, that is why you need to know those contact forces and action at a distance forces or the non-contact forces. Dapat kabalo ka ato nila. Kano sa ni sila ma-exist ng mga forces. O say mga symbols ani, just like here, there are symbols. Kay symbols na naman natong ginabutang. So, if it's F norm or Fn, that is normal force. If it is F app, that is applied force. If it is F graph or Fg, that is weight or gravitational force. Then F fric is the frictional force. So, magamit to siyang mga symbols na ako ang discuss or ako ang i-introduce ganina sa types of forces. Okay, so for example, we have here, a book is at rest on a tabletop. So, diagram the forces acting on the book. Okay, so the book. Let's say that this is the book. The square is the book. So, tanan na pag-drawing nimo square ra gyud na siya. Tanan na object maski unsa iyahang shape, it is square sa pag free body diagram. Okay? So, the book is at rest on a tabletop. So, the book it has weight. So, that is the FG. So, since it is resting on a tabletop, na siya F, oops, sorry, straight na siya. That is F norm. And that is the free body diagram of a book resting on a tabletop. Inga na ra. Okay. Okay. So then we have another example. Okay, so actually this will be my second example. Then ang uban na may example is himuon nako siyang performance task ninyo. Okay? So because this is very easy. Easy naman ni siya. Okay, so here we have a gymnast holding onto a bar that is suspended motionless in midair. The bar is supported by two ropes that is attached to the ceiling. Attached to the ceiling. So diagram the forces acting on the combination of the gymnast and the bar. Yun siya na gymnast is holding to a bar, suspended motionless in a mid-air. So our object here is the gymnast. This is the gymnast. Okay. Okay, holding onto a bar that is suspended motionless in a mid-air. The bar is supported by two ropes that is attached to the ceiling. Okay, so this object here is the gymnast and the bar. Okay, so gymnast plus the bar. That is your object. So, ningon siya dire na the bar is suspended. Tama ba? Suspended. Supported by two ropes that is attached to the ceiling. So if this is your gymnast and the bar, your bar is suspended with two ropes to the ceiling. So since these are ropes man na siya. So the force acting on that ganishang bar is what we call a tension. F tense and F tense. Okay, now, of course, gymnast and the bar is a matter na sila weight. So that is FG. So that is the free body diagram of this this situation. So holding onto a bar that is supported by two ropes. Diagram the forces acting on the combination of the gymnast of the bar. So you might be wondering, ma'am, nga gisagol man nimo ang gymnast ug ang bar? Combination of the gymnast and the bar. So depende na siya sa situation kung isagol ba ninyo siya or dili. So kani siya giingon man siya na isagol ang gymnast ug ang bar, mo nang ngani siya. Ngani ang ato ang object. Okay, so this is the free body diagram of that. Okay, so another example na lang ta. Okay, here is the egg is free falling from a nest in a tree. Neglect air resistance, so walay air resistance. Diagram the forces acting on the egg as it is falling. So if this is the object, which is the egg, free falling man siya, and if you have if you remembered our free-falling na discussion, an object can only be in a state of free fall if the only influence is just gravity. Wala na ilaing influence. And here, the force of gravity, ang force nga na ay G, is the Fg. And Fg is your weight. So it means in this, if it is free falling and you neglect air resistance, then the egg will only have this free body diagram. Iyahang weight ra. Okay, I hope that is clear. That is because it is free falling. Free falling means ang gravity lang ang iyahang influence. But since the force of gravity is the weight itself, so that is why isa ra ang iyahang arrow. Pwede din na ma'am, yes, if it is in a state of free falling. Okay. So, while the other examples will be given to you in a form of performance task number 2 that I will, I think, nasend na nako sa inyo ha, together with the link of this video. Okay. So, before that an object in motion will remain in motion with the same speed and the same direction, and an object at rest will stay at rest unless na ay unbalanced force na magpa-move or mo-stop sa ilaha. No? So, kaning statements of Newton's first law of motion, kaning unbalanced na force na iyang pasabot, kana siyang unbalanced force, it refers to the forces that is not cancelled. Mga forces na wala nimo na cancel. Okay? Or nabilin na mga net force. Diba pag net force nimo is 0, then it means your forces are balanced. Pero ug naa gali bilin ang imong net force, it means your forces is unbalanced. Okay, so pag dili siya 0. For example here, example of unbalanced force. Oh, sorry. Okay, so for example here, we have the F graph of 800 newtons downwards. Then we have 1,200 as our tension going upward. So, kani siya is naa kay unbalanced force. Pilay mo hang bilin. Okay, 1,200 minus 800. So that is an F net of 400. Okay, so it means you have a net force of 400 going upwards. Ano man, kisya may mas dako. Kung kisay mas dako na nga force, it means kini siya makancel niya ang 800 nga naa diri kay 1,200. So wala na ni siyang F graph diri. So pero naa siya bilin nga 400. So it means the F net or the unbalanced force is going upward. Okay, I hope that is clear. So naa siya net force or naa siya bilin nga 400 upward. So kung kinsa tong mas dako, mao na siya ang iyang direction sa iyang nabilin nga net force. How about this one? Here, we have weight of 800 newtons. You have an air resistance of 600. So, makancel ang 600. So, 600 diri sa ubos. So, nakaibalin nga 200. So you have 200 newtons downwards. That is your F net for this one. 200 downward or negative 200. Pwede na siya. Pwede siya 400 upward or positive 400. Pero usually, mag-good na ginabutangan nila nato siya direction gid mismo kanira kung prefer. That is because negative 200 can also mean going to the left. Okay? Okay, negative food ba ang going to the left. So that is why I prefer this. Downward, upward, left, or right. Ano siya. Okay? So, next, we have this. We have the F graph of 50. We have 50 newtons and we have normal force of 50. So it means cancel ang iyahang Y. But na siya'y bilin nga 20 newtons that is going to the left. So it means this part here has the net force of 20 newtons to the left. Kay siya ramay nabilin na wala na cancel sa ilaha. Okay? So that is what we call the cancellations of forces. So, sila tulo, naa sila'y unbalanced force. Okay. So, now observe the diagrams here. Okay. So, pag pareho sila o direction, as you can see here, pareho sila nga going to the right, 5, plus 5, another 5, so it means pwede nato sila i-add. As long as pareho sila direction, pareho sila, pareho sila direction. And pareho sila og axis. Okay? So here, if it is going to the right nga 5, and going to the left na 5, makancel nato na sila. And pag makancel sila, of course, their net force is 0. You have a balanced force. Balanced. So, pag the same o direction, 5 going to the right, and 10 going to the right, pwede na to sila i-add, it becomes 15. Pero, pag 5 going to the right, 10 is going to the left, then the net force is going to the left, and that is 5, or negative 5. Okay, kaya mas dako man ni siya, so it means siya ang mo-prevail nga direction. Kisay dako nga force, mao na siya ang iyahang force na direction. So, iyahang net force na direction. So, 5 going to the right and 15 going to the left, then it means your net force is going to the left, that is 10 newtons. Okay, mas dako man si 15. Okay, pwede po siya sa vertical. So, vertical, if it is going upward, na 10, and going downward na 5, so ang mabilin is the positive 5. Okay, mas dako man ang going upward. Okay, so I hope you're na-follow ninyo siya nga concept. Kay naamang po gihapon ni siya sa ato ang discussions before sa vectors. If you have remembered the vectors nato na discussion, ingani rin ni siya. Okay? So as long as they are the same nga axis, no? So pag vertical sila, vertical ra pod ang dapat nimo i-add o i-subtract. Pag horizontal, horizontal ra pod. Dili nimo pwede isagol ang horizontal o ang vertical. Okay? No, pa itong ganina, ibalik ra. No, 400 newtons up, 200 newtons down because of this. 200 newtons left because of this. So, a net force causes an acceleration. Tungod kay naa kay nabilin na mga forces, it means you have an unbalanced force. And once you have an unbalanced force, dili na siya saklaw sa first law of motion, which is the law of inertia. Because unbalanced force means you will have acceleration. Or acceleration is not equal to zero. No, kay katong sa atong first law of motion, maski rest siya and maski in motion siya, the acceleration is equal to zero. Because the forces are balanced. But if it is unbalanced force, your acceleration is not equal to zero. And that causes acceleration if your net force is not zero. So sa ilaha tulo dire, kinsa ang naay acceleration? Okay. So this car here has acceleration. Yan naman. Naay changes sa spaces sa iyahang dot motion. No? So digkit siya, so it means gagmay pa ang iyahang motion until sa nag-separate, dagko na kaayo. So it means there is a change in their motion. So naa siya acceleration. Here, number 2, they are equal. So pag equal sila or constant ang iyahang motion, so it means walay acceleration. No acceleration. And this, dagko, and then pag-abot diri ani gamay siya. So, because of that change, it means na siya'y acceleration. So, net force can cause an acceleration. Now this, as you can see here, it is in a straight line. And based sa ang discussion before, pag straight line gali ang imohang velocity, so it means you have no acceleration. Constant imong velocity. So wala ni siya acceleration. Here, this going downward, so you have a negative acceleration. A negative acceleration or deceleration, but still it is acceleration. Karipod is positive acceleration. Okay, so it means kani sila duha naa sila net force, or their net force is not equal to zero. Naa siya net force. Pero kani balance ang iyahang net force, or I mean balance iyang forces, the net force is equal to 0. Lahat diri is not equal to 0. So we have more examples here. We have situation here. Okay, so situation A, we have situations here, then you tell me if pila ang ilahang net force. So what are their net forces? So here. So situation A, we have the weight, which is 3 newtons. Na siya yung normal force nga 3 newtons. So it means pwede nato sila makancel duha. Now here we have applied force of 5 newtons. Then we have friction, which is 5 newtons. So it means the net force for situation A is 0. Now we have situation B. We have weight of 3 and normal force of 3. So it means cancelled ang atoang vertical. But naatay bilin nga 5 newtons. And that is going to the left. So it means ang iyang F net or iyang net force is 5 newtons going to the left. Something like that. Okay. So I also have different situations. Okay. Now, this will be part of your performance task 2 also. No? So, apil gyapon ni siya sa inyong performance task 2. So, you can review this. Kani siya para sa pag-answer ninyo sa inyong performance task 2. Okay. Then, we will have the law of acceleration. So, dire sa nako i-cut ang part 2 sa Newton's law, and then we will proceed with the law of acceleration sa part 3. Bye.